Good morning, students. Today, good morning, students. Today we will discuss about surface areas volumes. Before that, first we will discuss about formulas, whatever we used in surface areas volumes, as well as aerated circles. And the cuboid, it is length. It having length, breadth, height, and volume is defined as lbh cubic units. Its surface area, nothing but TSA, is defined as 2 of LB plus BH plus LH, and CSA is 2H of 2H of L plus B. CSA of cuboid is 2H of L plus B. Square units, as we know, area is square, will measure in square units. It is CSA 2H of L plus B, and volume LBH, and length of length of diagonal, nothing but the longest rod which we can put in cuboidal formula is root over L square plus B square plus H square units. And for cube, same, volume is A cube, and surface area, nothing but TSA is 6A square, and CSA of CSA of cube is 4A square units. 4 into edge, a square units, and diagonal is root 3 units. Cylinder, where R is radius, H is height, then volume is pi r square H cubic units. Curved surface area 2 pi r H square units. TSA 2 pi r of H plus R square units. For cone, radius R, height H, and it contains slant height also. It is called slant height. This is slant height, and perpendicular height. This one is perpendicular height, and radius. These all forms a right triangle. So slant height L square equal to H square plus R square. From that we can get L equal to root over H square plus R square. And volume is 1/3 of volume of cylinder, 1/3 pi R square H. And curved surface area pi R L, well, where L is slant height, and total surface area pi R L plus pi R square. We can write pi R of L plus R also. If you factorize pi R of L plus R is the TSA surface area of a cone. And sphere, it contains only surface area, CSA, TSA, LSA, everything same, 4 pi r square. Volume is 4/3 pi r cube, and hemisphere is the volume of volume of sphere, 2/3 pi r cube. And curved surface, it contains curved surface area. For hemisphere, it contains curved surface area as well as TSA. Curved surface area of hemisphere is 2 pi r square. TSA is 3 pi r square, as base is circular shape, and 1 liter equal to 100 centimeter cube, and 100 liters equal to 1 meter cube. You need to remember conversion of units. Let us go with next. These are the formulas from areas and related circles. Circumference of circle 2 pi r, area of circle pi r square, where r is radius. If diameter is given, we'll find radius by taking d equals to r by 2, and area of semicircle pi r square by 2. Area of circumference ring, it is the ring formula pi r of capital R square minus small r square, simply pi of capital R plus small r into capital R minus small r, and it is called arc. This is minor arc, and the rest part here it is major arc, minor arc. Length of arc formula L is theta by 362 pi r, and 2 to cancel, we can use both the forms. Length of major arc is called 360 minus theta by 360 to 2 pi r. If it is theta 60, 360 minus theta will be reflex angle 300 degrees, like that we do. And we go with next formula, and this is a tabular formula. Brief explanation about each formula, which is related to circle, semicircle, quadrant, ring, sector, segment. And segment formula we will use pi r. Instead of this one, we can write r sin theta by 2 cos theta by 2. So here sector formula theta by 360 pi r square, and perimeter 2r plus, actually 2r plus L. Simply we can write L plus 2r. Perimeter of sector is 2r plus L. Length of arc. Length of arc formula what's means theta by 362 pi r. That is why. And here area of major sector means 360 minus theta, because theta is occupying minor sector. So 360 minus theta will be, rest part will be major sector. So again, major sector the same way. Minor, I mean length of arc L formula will use 360 minus theta is reflex angle of theta. And next segment it is called small segment. This is minor segment, this total, except that rest part, this total part is major segment. Area of segment formula in general theta by 360 pi r square minus half r square sin theta, but don't use this formula students, use this formula only. Sin theta, it is a compound angle, you learn in higher classes. Instead of these two formulas, simply use this formula. 1 minute. So simply we'll use this formula only, easily to do. So don't use this formula. This is sometimes if they give more than 90, not possible. This is difficult for you people. So this one only use of r square theta by 180 pi or else r square. You can write like this r square uh, pi r square minus r square minus 2 sin theta by 2 cos theta by 2. So r square we can write like simple form r square of uh, theta by 360 pi minus sin theta by 2 cos theta by 2. 2 is factorized. Sin theta by 2 cos theta by 2. That is simple method. Sin theta by 2 cos theta by 2. This is discussed even area related circles formula also. In the chapter also we discussed. So these are the main formulas. Now let us do with some problems, models on surface areas volumes. How many balls each radius 1 centimeter can made up of solid sphere lead of radius 8 centimeter? Simple. Solid sphere, bigger sphere is R1. Let us take R2 1 centimeter. So volume of sphere formula 4/3 pi r cube. Volume of 4/3 pi r cube. So volume of solid sphere should be both should be equal. So n into 4 by 3 pi into 1 because here radius is given 1 centimeter. Bigger radius is 8 is given. Transpose it will become and these two get cancelled. 512 small balls are possible. I mean volume of bigger volume by smaller volume. If you do directly you get 512. Next problem. A spherical ball of radius 3 centimeter melted and recast into spherical balls. The radii of two balls are 1.9 and 2 centimeter. Determine the diameter of third ball. I mean here combination of three balls equal to bigger ball which is 3 centimeters. Let us find the volume of each ball separately and let us take third ball as 4 by 3 pi r cube. Sum of these three balls volumes equal to volume of bigger volume. And 4 by 3 pi is factorized. If you factorize 4 by 3 pi, 4 by 3 of 4 by 3 pi of r1 cube plus r2 cube plus r cube, unknown we took r cube, equals to last volume is given 4 by 3. This is r3 cube equals to 4 by 3 pi r cube. So 4 by 3 pi r cube means here 4 by 3 pi is common. We can cancel 4 by 3 and pi over both the sides. It is left over r cube. This is cube students. So cube. This is cube. So volume is cubic units. R cube. Here it is given clearly r cube. So r cube, this is cube, r cube plus 1.5 whole cube plus 2 cube equal 3 cube. Simplify, we get 2.5. So 3 ones are 3, 2.5. Let us go with the next problem. So diameter they ask 2 into 2.5, 5 centimeters. And 2 cubic diameter. Diameter means we'll convert into centimeters by dividing diameter of a grass to be drawn into cylindrical wire and to 0.25 centimeters. Find the length of wire. So that much if you from that glass if you do this much and the volume of bigger volume by smaller volume if you do, you get the length of wire, that is h. So generally these all both are in cylindrical shape, so use formula pi r square h, equate both the volumes and simplify. then we get the volume in terms of meters. So next, 50 circular plates, each diameter 14 centimeter, thickness 0.5 centimeters, are placed above one another to form a cylindrical shape. Find the total surface area. So how many plates are there? Diameter is 14, so radius. Thickness is nothing but height. How many plates are there? 50 plates. Such type of plates are there. Total height is 50 into 0.525 centimeters. Total surface area we need to find, that is nothing but 2 pi rh plus 2 pi r square, or 2 pi r of h plus r. 2 into pi value 22 by 7 into 7 according to radius, and substitute h as 25 we got here, 7 r, and simplify, we get surface area as 1408 centimeter square. Again, a path 2 meters wide around the circular pond, diameter 4 centimeters. How many cubic meters of gravel are required to grave the path depth 20 centimeters? So again, here also we'll use the concept of volume. Concept of the volume thickness is because it is a larger radius minus smaller radius, we get here capital minus smaller. Capital minus smaller, so we have 2, that is 2 with 22 meters capital. So we have formula hollow cylinder pi of capital R square minus small r square h, pi into 22 square minus 20 square. According to formula, you get 20 and 22 is given because width is given 20, so capital R is 20 plus 22, because if we transpose this side, 20 plus 2 22. So 20 we have smaller radius, bigger radius 22, substitute and multiply, then we get 52 pi meter cube of gravel is needed for depth of 20 centimeters path. The next 1.6 meters, 1.6 meters width, diameter 3.5 meters, dug up and earth from spread evenly platform, and it is forming a cuboidal form. So according to question, volume of cylindrical shape, depth. I mean, this well will be in the shape of cylinder. So volume of cylinder equals to volume of rectangular platform LBH. Height is not known, x, and length we know 27.5, breadth is 7 centimeters, and substitute and equate both the volumes, because the volume of mud which is dug out from the cylindrical volume is overall spread as a cuboidal path. So both volumes are equal. Substitute LBH form equal to and after substituting both are equal, so we have 32 by 7 1.75 whole square into 16 equal to 192.5 x, from 1 and 2 x, we need to transpose this side and simplify, you get 0.8 centimeters, 0.8 meters, convert into centimeters, 0.8 into 100, 80 centimeters. Here do cancellation in your own way, that is so 7 ones are 7, 1.5 is again 1.75, 192.5. We simplify, we get 0.8 meters, because every value is given meters, convert into centimeters by multiplying by 100. And again, the well diameter 2 meters is dug out 14 meters depth. The earth is taken and spread evenly around the form of embankment. Embankment means which is path to walk. Height is 40 centimeters. Find the width of the embankment. Same process we do, and we'll take let width of the embankment is x. Equate both the volumes and substitute. We get the width of the embankment as 5 meters. After doing simplification, pi get cancelled and simplify, we get the answer. Next, find the volume of larger circular cone that can cut off from cube in a cube edge 9 centimeters. Even edge of the cube is 9 centimeters. Given largest cone curve surface area and diameter of the base of cone must be equal to side of the cube. So 2x equal to 9. Radius will be 9 pi 2. Height of the cone must be equals to side of the cube, that is nothing but 9 centimeters. So substitute volume of larger cone equal to 1/3 pi r square h. Once again I am saying diameter of cone must be equal to edge of this cube. Height of the cone must be equal to edge of the cube. So substitute the values and simplify. We get 190.292 190.92 centimeter cube. That largest cone. And hollow sphere internal external diameters are given, melted into A cone based diameter, calculate the height of the cone. So we need to find volume of sphere. If it is hollow sphere, we know outer volume minus inner volume. We do 4 by 3 pi capital R cube minus small r cube. This is cube, students. So b cube 4 cube. So simplify and take it to 8 centimeters. Volume of cone is 1/3 pi r square h and equate to both the values. As we know, 4 square value is 64 because it is given 4 and 8. So substitute the values, we get the simplification value, that is here. uh, we have to simplify this value and diameters are given. This is 2 and this is 4 square, and after substituting these values we got uh, 4 by 3 pi 48 by 1 by 3 pi 16. So 3 pi cancel, 3 cancel. After simplification we got height equal to 12 centimeters. The diameter of metallic sphere equal to 9 centimeters. The metal drawn into long by 2 millimeter uniform cross section. Convert everything into centimeters. So we get that. So volume of sphere, actually sphere to cylindrical form. By reason cylindrical form, equate both and simplify. We get 1200 150 centimeters. Again we can convert into meters. 1200 150, if you divide by 100, 12,000 centimeters we got. If we divide by 100, we get 12 point at 121.5 meters. This much length of wire is available from the sphere by recasting. Next, diameter of internal and external hollow spherical cell are Canon 6 respectively. Melt recast into solid cylinder to 2 by 3 centimeter. Find the diameter. Already just now we did same model. We'll apply volume concept, that is 4 by 3 pi r cube, capital R cube, small r cube, 5 cube minus 3 cube. Then we get 125, 125, 27 and simplify. We get the value. Radius is 7 centimeter. Diameter is 2 times 2 radius, 14 centimeters. Next, how many 1.75 centimeters diameter, 2 millimeter thickness must be melted to form cuboid. So volumes will be equal. Volume of cylinder must be equal to volume of cuboid. Then volume, after that we get n into bigger volume by smaller volume, 11 into 10 into 75. If you take and then simplify the values, we get 1600. So such 1600 coins are possible. So here volume of hemisphere 22,425, 1 by 2 centimeter. Find its curve surface area. We know 2 by 3 pi r cube and equate these values. Write mixed number to improper fraction. We know the volume of formula and r cube equal to reciprocal. Do cancellation here. After doing cancellation, we got r cube, r equal to 10.5 centimeters. Substitute in a surface area 2 pi r square, we get 692.72 and 692.72 approx value 693 centimeter square. This is the surface area of the hemisphere. Next, a tent is in the form of right circular cone, right circular cylinder surmounted by cone. So we need to, the diameter of cylinder 24 meters, the height of the cylindrical portion 11 meters, while the vertex of cone is 16 meters above the ground. Find the area of canvas required. Here we know sum of cylinder, CSA of cylinder plus CSA of cone we will take, and according to question, radius is half of diameter 12 meters and its height is given 11 meters and height of cylindrical part 11 meters. Height of conical part is 5 meters according to given question. 16 is total height. In that 11 is cylindrical part means cone will be 5. 11, 16 minus 5. So we get 11. Sorry, 16 minus 11 because 11 is height of the cylindrical part. So we got after that pi r l slant height we need to find l. We know that l equals to root over s square plus r square. Substitute we get 13 and after simplification we have this value and we have 2 pi r h and we know both sum of both the CSS is nothing but area of convex needed, but width is when width is given divide by sum of CSS by width we get. So finally we got 1320 meter square of canvas is needed. 1320 meter square of canvas is needed for preparing this tent. Next, a circular tent has cylindrical shapes are mounted by conical roof, same model to previous, and cylindrical base radius is given nothing but height of the cylinder and conical separately given. So substitute will find the CSA separately and add up. But here it is given that how much volume of tent. Find the volume of tent is given. See, if they want area of canvas needed, CSA of cone plus CSA of cylinder. But here volume of tent is means volume of cone plus volume of cylinder. So 1/3 pi r square h pi r square h heights are different. H1 h2 we take radius is same. Substitute simplify. We get 880 5280 both if we add 6160 meter cube. This is the total volume of tent. Next question is given volume in a canal 1.5 meters wide and 6 meters depth is flowing with a speed of 10 km per hour. How much area it will irrigate in 30 minutes if 8 centimeters of standing water is desired? Volume of volume of water we can define as area into height also. Here height of the water level is given, so volume of cuboidal canal equals to volume of that irrigated place we can take for 30 minutes means 10 into 30 by 60 kilometers, that is 5000 meters to convert into meters. So volume of flowing water in 30 minutes equal to 5000 into width into depth, that is nothing but here width is given 1.5, depth is given 6 meters. So 5000 into 1.5 into 6 equal to 45,000 meter cube of water is irrigating. But irrigating 30 minutes in 8 centimeters. So 45,000 divided by 0.08 and convert decimal form to 8 by 100 we can take and simplify. We get 55 lakhs 5 lakhs 62,500 meters square. We can convert it into hectares by dividing by 10,000. As we know 1 hectare equal to 10,000 meters square. So 5 lakhs if you convert 5 lakhs 62,500 into hectares divide by divide by 10,000 we get the value in hectares. From meter square to hectares, whatever possible cancel it, then we get the value, students. So 5 lakhs 62, so 0 cancel, then after we have 56.25 hectares. 56.25 hectares is the in hectares, it is in hectares. Let us go with the next problem. So here it is given a conical drilled circular cylinder, height 12 centimeters, base radius 5 centimeters, the height and base radius of cone also same. Find the whole surface area and volume of remaining cylinder. Base radius is given 5 centimeters and height is 12 centimeters. The slant height is we need to find because it is a conical shape. CSA of conical shape is pi r l, so we need to find L by using relation between radius and height, that is root over r square plus x square. We got 13. So height base radius is given 2 pi r h is CSA of 2 pi r h is CSA of cylinder. Pi r square here base is closed, so pi r square is included. Pi r l CSA of cone. Above part is closed, opened. TSA equals to, if we substitute and simplify, we get 210 pi centimeter square. That is TSA of that solid. So volume of remaining part equal to volume of cylinder minus volume of cone, pi r square h minus 1/3 pi r square h, where r is 5 but height is same. So after simplification we have 200 pi centimeter cube. Let us go with next problem. So next problem is given a tent is in the form of cylindrical, diameter 20 meters and height 2.5 meters, surmounted by a cone, height 7.5 meters. Find the capacity of tent and cost of canvas needed for 100 per meter square. Capacity means volume, will find volume of cylinder plus volume of cone, and then after we need to find a total capacity we found. If they want to find cost of canvas, we will find CSA of cone, a CSA of cone plus CSA of cylinder into 100. We have done two more different models previously. So substitute, we got 5,500 pi centimeter square, 5 centimeter cube of capacity means volume. So we take next that will find here the solid shape of surmounted hemisphere here. Before it is cone and cylinder, now cone and hemisphere. Same way, volume of, we find volume of solid, volume of cone plus volume of hemisphere, volume of cone 1/3 pi r square h, and the volume of hemisphere is 2/3 pi r cube. Substitute and simplify, we get the values, add up, simplify, we get 166.75 centimeter cube. Calculation part you can do in your own way, students. So let us go with the next slide. Next slide is given a cubical block of 5 centimeters and surmounted by hemisphere. What is the greatest diameter of hemisphere can have? I mean, it is nothing but edge of the edge of the edge of the cube, nothing but side diameter of the hemisphere possible from the total surface area, where pi is 22 by 7. Unless until they give 3.145 value, we'll take 22 by 7 only. From the, if you draw this figure, you can see this is diameter, highest diameter, which is nothing but edge of the cube 7 centimeter, as radius 7 by 2. And we know that total surface area equals to, we discussed, surface area plus CSA of hemisphere minus area of the base, because area of the hemisphere is repeating two times. For one hemisphere, one already cube is there. So 6 edges square plus 2 pi r square minus pi r square. If we subtract pi r square from 2 pi r square, pi r square. Substitute the values, simplify and do cancellation in your way. We got 294 plus 38.5, which is 332.5 centimeter square. And if you have any doubt, please contact this number, students. Thank you and keep on watching. I'll do rest of the chapters also, which is useful for final exam point of view. Thank you, students. Keep watching and subscribe, share, and you can ask me doubts in through this WhatsApp number. Thank you.